In this video, I'm just going to go through one example from our notes of how we curve sketch. So this means I'm going to find out what this function looks like without even touching my calculator. Just get an idea here. So first thing we're going to do is find what the function zeros are, and that includes multiplicities. So this first one here, I've got x is equal to 0 from this factor, x is equal to 1, and x is equal to -1. Okay, the y-intercept, if I want to find this, I'm going to evaluate the function at x equals 0. So for y-intercept, if I plug in 0, I get 0 times, this will be -1 and this will be 1. But if I'm multiplying everything by 0, well, then that's just going to be 0. So at y equals 0, there's going to be an intercept. The degree of this polynomial would be 1, 2, 3. Okay, so this is a degree 3. It's a leading coefficient that's positive, so that means that we're going to end positively. So this is my end behavior. Okay, and now we're going to determine the sign values of the function between the zeros, which is what we call partitioning the number line. So I'm going to have a number line here. And what I'm going to do is put the zeros in order along the number line. So -1, 0, 1. I'm actually going to move my y-intercept work. I'll move this like up here for now. Okay, so then I'm going to put the factors along the left. So I've got x, x minus 1, and x plus 1. Now what we do is pick a number in this interval and we plug it into the factors. So like any number in here, it could be -2, -5, -1,000. If you're going to plug it into x, the result is going to be negative. If you plug -1,000 in here, that's also going to be negative. And then same thing here. Okay, a number between -1 and 0 is something like, I don't know, -1/2. And it could be anything in this. If I plug -1/2 in here, it's going to be negative. If I plug -1/2 in here, that'll end up being a negative result. And then lastly, if I plug a -1/2 in here, it'll go positive. Okay, one more to do. Between 0 and 1, how about 1/2? So go positive. 1/2 minus 1, that's still negative. And then, actually, no, I have a couple more to do here. And then 1/2 plus 1 is positive. Okay, now lastly, how about 100? If I plug 100 in, it's going to be positive. 100 minus 1 is still positive. 100 plus 1 is also still positive. Something else to note here is that the root of x plus 1 is -1. So everything to the left is negative, everything to the right is positive. The root of x minus 1 is +1, so everything to the left is negative, to the right is positive, and the root of x is 0, everything to the left is negative, everything to the right is positive. Okay, so now what we do is multiply down these columns. A negative times a negative times a negative is a negative. Okay, negative times a negative is a positive, times a positive is a positive. Positive times negative makes it negative. And then lastly, all these positives multiplying together is positive. Now what this tells you is whether the function is above or below the x-axis. So if it's negative, that means it's going to be below. And if it's positive, that means above. Now we know the end behavior. It's got to start below the x-axis. So I'm just going to set up my axes here. Okay, and I'm going to mark the zeros first. Remember, it's going to hit the x-axis at -1, 0, and 1. I know based on my work that the function has to start below when I'm to the left of -1. So just like that. Then it goes above. And then it's got to come back down and hit at 0 again, which is also the same thing as the y-intercept, 0, 0. So I'm going to go up and then come back down. I don't know how high up this is. I'm just guessing. and then back down. Okay, now I'm back at the x-axis. Now I'm going to go below the x-axis. And then I got to come back up and hit this 0 again at 1. And then I'm going above the x-axis and finishing. And you should see how this is matching what I said my end behavior would be. I'm finishing positively. Okay, and that's curve sketching. All right, I'll actually do one more because I want to talk about when there's a multiplicity of 2. So if we look at our zeros here, it's 1, 2, -3, and we get -4 twice. Okay, so that's a multiplicity of 2. Okay, the y-intercept, if I were to evaluate this at 0, I get 0 minus 1 is -1 times -2 times 3 times -4 times -4. And that gives me 96. So my y-intercept is occurring pretty high. Okay, so now what we're going to do is partition the number line. I'm going to write x plus 4 twice. Okay, and then along my number line, we've got, in order, -4, -3, 2, oops, sorry, 1, then 2. Okay, now I'm going to fill in. Okay, so I know that the root here of the divisor is 1, so everything to the left will be negative, everything to the right is positive. The root of x minus 2 is 2, so everything to the right is positive, everything to the left is negative. Oops, kinda. Okay, for 3, we're at -3. Everything to the right is positive. And then for x plus 4, the root is -4. And then everything else to the right is positive. Okay, so now I multiplied down the columns. So positive, positive, then it goes negative. This will be negative, positive, negative, positive. Okay, something I didn't mention is that the degree of this would be 1, 2, 3, 4, 5. This is a degree 5. And it's going to have end behavior like that. It'll end positively. Okay, which matches my number line here. Okay, now what you should notice here is that there isn't like an alternating sign pattern like there was above. It goes negative, then negative. That means there's a kiss in the graph at -4, which is what we would expect with a multiplicity of 2. Alright, so I set up my axes here, and I actually adjusted the scale on my y's so that every box was worth 8, so that I could hit this y-intercept at 96. My intercepts, I got a label here, so I've got 1, 2, -3, and oops, this would be -4. Okay, so those are where I have to hit the x-axis. I'm starting below the x-axis when I am to the left of -4. So just like my end behavior says, it should look like that. But at -4, see how I don't go, like past -4, I don't go above it. I just kind of kiss it. So I'm going to go negative again. And then I got to hit the x-axis at -3. Then I'm going above. But then I got to come back, remember, and hit the x-axis at 1, which that means I'm going to go all the way up, hit my y-intercept at 96, and come back down. Okay, then I go below, because this says negative, and I'm going to hit at this x-axis at 2 again, and then I'm going to finish positively. And this is our function f of x. Okay, my end behavior matches just as I anticipated. There's a kiss in the graph because of that multiplicity of 2, and everything else is crosses because they had a multiplicity of 1.